Okay, so they want us to add them, but to be able to add radicals or subtract them, the radicands have to match. This is a radicand of 27. This is a radicand of 75. So currently we cannot add them like they want us to, but we can attempt to make them match by simplifying both of the radicals using factor trees. What are factors of 27? And then 9 breaks down into 3 times 3, and then that 3 just drops because it's prime. Now that they're all prime, you circle any pairs, kill one, kick one out, put the uncircled one back inside the house. So now we have simplified the square root of 27. It's 3 square root 3. Now I'm going to do the same thing to the square root of 75. That would be, okay, or 25 and 3. Either one would work. 25 breaks down into, right, and then 3 is prime, so it just drops. Now that all the numbers are prime, I circle any pairs, kill one, kick one out. Anything uncircled goes back in the house. Now that that one's simplified, now we can attempt to add them again. They now match, but these are like terms, so you don't actually change the like term. You keep it the square root of 3. The only thing you actually add are the outside numbers, the coefficients, and 3 plus 5 is 8. Okay, and then like always, you check your work. You go to your calculator, you type in the square root of 27 plus the square root of 75, and it says that it's 13.856. Then you type in your answer, 8 square roots of 3, and you see that it's the same thing. So that confirms for you that you've done it correctly. And guys, since you have 90 minutes in this class and you'll have plenty of time to take the test, there's no reason that you should not be checking your answer. Okay, you have plenty of time. You should always be checking your answer, because if these come up not matching, you know to start over and try the problem again. Okay, now before we start going over the review sheet, we do need to finish up a couple of problems back in the packet that we skipped over. So go to page 18 in your packet. Okay, number 3, remember, this is, the background of this is you were going on a cruise, you figured out how many nautical miles it was going to be, but later the ship sank and it was discovered 38 fathoms deep underwater. But fortunately you survived, and you are now stranded on a deserted island that is located 12.5 degrees north of the equator. How many miles is this if 1 degree equals 69.047 miles? So what will we start our conversion chain with? Right, 12.5, and then to write degrees, you just write that little symbol. Okay, correct. We now multiply by a fraction, and like Krishad was saying, whatever's in the top for units now goes on the bottom. So degrees means degrees. And what did they tell us about degrees? Right. Okay, well, isn't that what they want the answer to be in anyway? Miles. How many miles is this? So you're now done with the conversion chain because you've made it to the units that they want the answer in. You cross out the other units. Degrees and degrees cancel each other out. In the numerator, you're left with 12.5 times 69.047. So go and multiply those. And we'll just round that to 0.1, I guess, and then that's miles. And so that's actually the final answer, because the bottom is just 1, and so there's no need to even write it. So that's how far you are north of the equator in miles. Okay, number 4 says to reach the top of the palm tree for a coconut, you will have to climb 7.4 meters. How many hands is this? So they're basically asking how many times will your hands go up the tree to get to the top if you're climbing 7.4 meters. And then they give you some information. 1 inch is 2.54 centimeters. 1 hand is approximately 4 inches, okay? So what do we start our conversion chain with? What? Right. You're going to have to climb 7.4 meters. So that's what we start our conversion chain with. Now whatever's in the top will now go in the bottom. So meters goes in the bottom. What is something they told us about meters? Centimeters. So to be able to use that, don't we need to convert meters over to centimeters first? Okay, so let me say that again in case you're confused. We're currently in meters, but the only information they gave us was in centimeters. So we need to first convert meters into centimeters. So look right here in your packet under length, and it says 1 meter is equal to 100 centimeters. So 1 meter is 100 centimeters. Yes, Krishad? Yeah, but not right now. For right now, just share, and then I'll get you one before the test tomorrow. You can just share with Karen today. Okay, now that we're in centimeters in the top, we put centimeters in the bottom, where we'll now be able to use this 2.54 centimeters is equal to 1 inch. Okay, now the inches is in the top, inches goes in the bottom, and we'll be able to use this 4 inches as 1 hand. And isn't that what they wanted your answer to be in anyway? They say, how many hands is this? So we've made it to the units that they want the answer in. Now we cross out all the other units, and we multiply the numerators, which are 7.4 times 100 times 1 times 1, and that gives us 740. And then we multiply the denominators. 1 times 2.54 times 4 is 10.16, right? And now we just divide. 740 divided by 10.16, and we get what? Okay, now this is hands, so don't we need to round it up to the nearest whole number because we're talking about somebody's hand going up the tree? So to get to the top, you would have to place the what hand on the tree? 73rd hand, right? Because if you just stopped at 72, would you be there yet? No, you have to at least place that hand a 73rd time to get to the top. So it's approximately 73 hands. All right, number 5 is a little bit different. Okay, and problems like number 5 are the reason we actually came back to this today before going over the review sheet, because I didn't do any like this. So everybody just put down your pencil for a second and pay attention, and then I'll give you time to copy. The island is also rich with hot chili peppers. You can collect 1.6 pecks a day. How many liters could you collect in 1 week? So of these chili peppers, you can collect 1.6 pecks a day. They want to know how many liters this is. So we start our conversion chain with 1.6 pecks, and I'm just going to abbreviate it like that. I don't know if that's correct, but now since pecks are in the top, I put pecks in the bottom, and they tell me that 4 pecks is equal to 32 quarts. But I can't stop there because they don't want the answer in quarts, they want it in liters. So now that quarts is in the top, I put quarts in the bottom, and they tell me that 1.06 quarts is 1 liter. Okay, so now go ahead and copy that, and then I'm going to continue once everybody has copied. Okay, it looks like everybody's finished copying, right? Okay, so look, I've now gone from pecks to liters, which is what they wanted me to do. Pecks to liters. I crossed out these units, but I'm not done. This one's different than all the other ones we've done so far. You're converting two different things. They want you to convert pecks per day to liters per week. So now below the 1.6 pecks, I'm going to put 1 day, because that's how many you collect in 1 day, right? But they want to know how many liters that would be per week. So I've got to convert these days into weeks. So now look, just put down your pencil again and watch so that you don't miss it. Days is in the bottom, so days has to go in the top. And don't we know that there's 7 days in 1 week? So now I'm done with the chain because I've made it to weeks. I crossed out days with days, and now look, I'm only left with liters and weeks not crossed out, which is good. That's what they want the answer in, liters per week. Now I multiply the numerators, 1.6 times 32 times 1 times 7, and that gives me what? Right, 358.4. And then in the bottom, I have 1 times 4 times 1.06 times 1, and that gives me what? 4.24. And now I just divide those. 358.4 divided by 4. Oops, I wrote too many 4s down there. 4.24. Hold on, let me erase this. And 84.5 is correct. And that is liters per week is how many of those hot chili peppers you could collect. So see how we basically just did 2 conversion chains in one? In the blue, I converted pecks to liters, and then I went back and in the red converted days to weeks. Okay, so now I want you to flip back to page 17. And go up to the very top one, number 6, and attempt this one by yourself. I'll give you about 3 minutes. No, we didn't do that one. Well, I didn't do it with y'all. So attempt it now because it's one like we just did where you have to do 2 conversion chains in one. And then I'll go over it. Number 6 on page 17. Look, you're converting 100 meters in 9.58 seconds to miles per hour. So first create a chain where you're converting 100 meters into miles. Then go back and create another chain where you're converting seconds into hours. So go. It says in 2009, Usain Bolt ran the 100-meter dash in 9.58 seconds. Find his average velocity in miles per hour. You may find it useful to know that 1 meter is 39.37 inches, 1 foot is 12 inches, and 1 mile is 5,280 feet. Okay, he ran 100 meters, and that was done in 9.58 seconds. Since meters is in the top, I put meters in the bottom, and I'm trying to get it to miles. So I start looking up here first, and they tell me that 1 meter is 39.37 inches. Now, you don't have to use the information they give you. Like I noticed Chris Schad converted, I think, meters to kilometers and then kilometers to miles. That's fine. Okay, you can use whatever you know from your sheet. But I'm just going to use what they gave us because I'm assuming that's what most people probably did. Okay, now I'm going to go from inches, 12 inches, to 1 foot. And I'm trying to get this to miles. So now I'm going to put 5,280 feet in 1 mile. Okay, so now I've made it from meters to miles. Now I have to make it from seconds to hours. Well, when we look at it that way, seconds is in the bottom at first. So I have to put seconds in the top now. And I know there are 60 seconds in 1 minute, but I'm trying to make it to hours, so I continue by putting minutes in the top. And I know there's 60 minutes in 1 hour. So that's what your conversion chain should have looked like. Now I'm going to cross out all the ones that will meters over meters, inches over inches, feet over feet, leaving just miles that wouldn't be crossed out there. And then seconds with seconds, minutes with minutes, leaving just hours that wasn't crossed out. And that makes sense that miles and hours were not crossed out because that's what they want the answer to be in. Now I just multiply all the numerators. 100 times 39.37 times 1 times 1 times 60 times 60, and I get a big number, so I'm not going to write it up here. I'm just going to leave it on my screen. It's 14,173,200. Now I'm going to do 9.58 times 1 times 12 times 5,280 times 1 times 1, and I get 606,988.8. And then to finalize that, I just divide those two numbers. So 14,173,200 divided by 606,988.8, and that gave me 23.35, and that's miles per hour. Did anybody get it right? One person, two people? Well, that's the same thing. 23.4 is the same thing. You just rounded to the 10th place where I rounded to the 100th. Okay, now we need to get out the review sheet and start going over it. Okay, so get out the review sheet. It looks like this. Number one, convert 8 kilometers to meters. You can do this one two different ways. We can do a conversion chain like we've done for all the other ones. We would start the conversion chain with 8 kilometers. Then you would multiply by a fraction. Since kilometers is in the top, we would put it in the bottom. We're trying to go to meters, so I would look at all my conversions on my paper that you'll be using tomorrow. And I will say, right here it says that 1 kilometer is what? 1,000 meters. Very good. So I would write 1 kilometer is 1,000 meters. Okay, then I would say kilometers over kilometers cancels out, leaving just meters, which is good because that's what they want your answer to be in. I would then multiply the 8 times 1,000 to get 8,000, and then the bottom is just 1, so that would just be 8,000 meters. Now, if you do not want to do it as a conversion chain, you can do it using the King Henry died by drinking chocolate milk. Okay, we currently have 8 kilometers. Well, with 8, isn't the decimal point just right here at the end? Well, if you're going from kilometers to meters, that's from K for kilo over to B for base, which means you move the decimal point 3 places to the right, and you fill in those 3 places with zeros, which gives you 8,000 meters. So either way you want to do it is fine. Yes? This? It's on the front of your packet. You lost your whole packet? Okay, well, you just need to share with your partner today, and I'll try to get some more printed for tomorrow because I just gave, I don't know if I have any packets left. Okay, number 2, convert 72 inches to feet. Okay, so what would we start our conversion chain with? 72 inches, right. Then we multiply, right, inches is in the top, so it goes on the bottom. We're trying to take it to feet. What do we know about inches to feet? Right. So now we're done with our conversion chain because we've made it to feet, which is the desired units for the answer. We cross out the other units. In the top, we have 72 times 1, which is 72. In the bottom, we just have 12. You then just divide those, and 72 divided by 12 equals 6. And that's 6 feet. Okay, any questions so far? Yep. All right, number 3, you are throwing a party and you want to buy 15 pizzas. Each pizza costs $7.25. How much will you pay to purchase the pizza? Hold on, Madison, you got a question or you want to answer? Okay, what's the answer? Right, and how did you get that? Right, you're buying 15 pizzas and they're each $7.25. So to figure out how much you have to pay for all of it, you multiply those, and that's how she got that answer. Pretty easy. Why? You thought it was harder than it was? All right, number 4. How accurately should the measurement of the width of a pencil be measured? Now, they are talking about the thickness of the pencil, not the length. So look over here at my ruler. Okay, from the end of the ruler to this line right here is an inch. So ½ an inch would be there. This thing, which is much thicker than a pencil, pretty much fills up ½ an inch. So what do you think a pencil might be? A ¼ inch. Look, right here to this first little line, which is, pretty thin, that's an ⅛ inch. That's too thin for a pencil, right? More like that, a ¼ inch would be a pencil. So C. It's about a ¼ inch. I would say something that's the thickness of an ⅛ inch would be like your cord on your phone charger. That would be like an ⅛ inch. Something similar. All right, number 5. Number 5. A classroom has a length of 10 yards and a width of 20 feet. What is the area of the classroom? Well, this wasn't there. I drew it in earlier because I know that a classroom is normally a rectangular shape. How do you find area of a rectangle? What's the formula? Length times width. Well, they told us the length is 10 yards. And then they told us the width is 20 feet. So what do we do? Okay, what do we multiply? Which is what times what? Which is? But is it 200 yards or 200 feet? But the 10 is in yards, so right. I heard Annette say earlier you've got to convert one or the other. Let's just pretend like they want your final answer to be in feet. Doesn't that mean we got to take this one out of yards and put it into feet? Well, what do we know about yards and feet? Okay, so if 1 yard is 3 feet, 10 yards would be 30 feet. Now that they both match when it comes to their units, now you multiply them. What is 30 times 20? 600, and that's square feet. You have to have them in the same units before you can multiply them. Because think about it, if you just did 10 times 20, yeah, you get 200, but 200 yards or 200 feet, it's two different things. So that's why they have to match. Any questions so far? Yes. They told you the length of a classroom was 10 yards. So on the length side, I wrote 10 yards. The width is 20 feet. So on the width side, I put 20 feet. They want the area, which means you multiply the length times the width. But the problem is you can't just do 10 times 20 because 10 is in yards, 20 is in feet. So we had to convert the 10 yards over to feet. There's 3 feet in every yard, so 10 yards is 30 feet. 30 times 20 now is 600 square feet. Does that make more sense? You have to convert them so that they match. After this little bell change, we'll keep working. Come in, get your pink sheet out right away. Number 6. The formula for force is F equals ma, which is force equals mass times acceleration. So I'm going to write that down here. If mass is measured in kilograms and acceleration is measured in kilograms per second squared, what is the unit for force? Well, all they're wanting you to do is replace the m and the a with what they're measured in. Mass is measured in kilograms. Acceleration is measured in kilograms per second squared. So to find the units for force, You just multiply those. Kilograms times kilograms is kilograms squared, because there's 2 of them. And then over second squared, and then you're done. That's all you do. You replace the variables with what units they're measured in, and then you just multiply them together because they're touching, which means multiplication. Okay, so look, M got replaced with kg because mass is measured in kilograms. A, acceleration, got replaced with kilograms per second squared because that's what it's measured in. And then they're touching, which means multiply them together. Kilograms times kilograms is kilograms squared. And then on the bottom, it's just second squared. That's all you do. Number 7, distance is described as D equals RT, which is distance equals rate times time. R is measured in meters, so I'm going to replace the R with M for meters. These are touching, which means multiplication. T is measured in seconds, so distance just equals meters times seconds. Or in our case, we measure in miles per hour, right? All right, now turn to the next page, number 8. Well, this page is actually a little easier than it looks, and this is how it will be on tomorrow's test. They start the conversion chain for you. The only thing you have to do is fill in the missing pieces of the chain. So it says you can drive 1,000 yards in 1 minute. They already put that for you, 1,000 yards in 1 minute. Convert this rate to yards per second. So think about what we're actually converting. What are they asking us to convert? Right, because look, yards is remaining in yards, right? So we don't need to convert the 1,000 yards, it's staying in yards. We just need to convert the minutes into seconds. Well, 1 minute's in the bottom, so doesn't that mean we put minutes in the top? And what do we know about minutes to seconds? Right, and you're done. That's all they wanted you to do is fill in the missing part. Okay, so now let's look at number 9. You have an apple tree in your backyard. You collect 1.6 pecks of apples each day. So see how they started the conversion chain with 1.6 pecks per day because that's how much you can collect? Then since pecks was in the top, they put pecks in the bottom, and they used the info that 4 pecks equals 32 quarts. That was given, so they used it. But we're trying to convert pecks over to what unit? Liters. Okay, so look, 32 quarts. Quarts is in the top, so don't we put quarts in the bottom? But our ultimate goal is to get to liters, so what could you use? Right here, 1.06 quarts is 1 liter. 1.0, well, it's just rounded differently. So that's all you do. You just fill in the missing part of the chain and you're done. You just have to know the rules of the chain, that if quarts was in the top, it now goes in the bottom. We're trying to get to liters, so we use this. 1.06 quarts is 1 liter, and then you're done. So there are going to be some questions on the test where that's what you have to do, just fill in the missing component of the chain. But there are other questions on the test where you actually have to do the whole chain by yourself. So let's try number 10 first. I'm going to do it with you, and then I'll give you time to copy it, okay? So just pay attention. You decide to drain your pool for the winter. The water drains out at a rate of 50 gallons per day. So 50 gallons of water drain every day. They want to know how many pints per second the water is draining. So don't we need to convert gallons to pints and then days to seconds? Well, we'll do one thing at a time. First, we'll convert the gallons into pints. So just don't worry about the days yet. Just ignore it. We're just converting the 50 gallons into pints. So, right. And we know, what about gallons? 1 gallon is 4 quarts. That's really the only thing we know right now. Then that means quarts goes at the bottom. And what do we know about quarts? Right. And weren't we trying to get to pints? So we're done with that part of the chain. We've made it from gallons to pints, which was the goal, gallons per day to pints per second. But now we have to continue with the chain from days to seconds. Well, days is in the bottom, so now days goes in the top, right? And then hours is in the bottom, so now it goes in the top, and we know 1 hour is, right? But we're not finished with the chain because we're trying to get all the way to seconds. So 1 minute is 60 seconds. Okay, now copy it, and then we'll continue simplifying. Okay, everybody got it copied? Okay, so now look. Gallons and gallons will cross out. Quarts and quarts will cross out. Pints won't, because was there anything on the bottom to cross it out? And it's not supposed to be crossed out because that's what we want our answer to be in. Then days and days will cross out, hours and hours, minutes and minutes. But seconds does not cancel out with anything because that's what we want our answer in. So now we multiply the numerators, which is 50 times 4 times 2 times 1 times 1 times 1, and that gives me what? 400. Then we multiply our denominators. 1 times 1 times 1 times 24 times 60 times 60, and we get, correct? And now we divide that. 400 divided by 86,400 is 0.0046, so I'll round it to 5. Remember, whatever number's on top gets typed in your calculator first. And that's pints per second. Well, doesn't it make sense that it would be such a small amount of water draining in 1 second? Not a lot of water is going to drain in 1 second, right? So that's why it's such a small number, because we're talking about a second. All right, now I want you to utilize what you just learned from there and what we did at the beginning of class today, and try number 11 by your feet per second. Okay, so we would start our conversion chain with 80 miles, and that happens in 2 hours. But I'm not going to worry about that 2 hours at first, because I'm just going to concentrate on converting the 80 miles into feet. So since miles is in the top, we put miles in the bottom. And I know that 1 mile is equal to 5,280 feet. So I've already done with that part of the chain because I've already made it from miles to feet, which was part of the goal, miles to feet. Now I need to continue the chain though, because I'm also converting hours to seconds. Well, hours is in the bottom, so it now goes in the top, and I know 1 hour is 60 minutes, but I'm not done because I'm trying to get to seconds, and I know that 1 minute is 60 seconds. Okay, is that what your chain looks like? All right, so now I cross out miles over miles, not feet. There's nothing to cross it out with. And then hours with hours, minutes with minutes, but not seconds. Okay, and that's what I want my answer in, feet per second, feet per second. Now I just multiply the numerators, which are 80 times 5,280 times 1 times 1, and that gives me 422,400. And then I multiply the denominators, which are 2 times 1 times 60 times 60, and that gives me 7,200. And then I divide those. You always type the top in first, so 422,400 divided by 7,200, and you get what? Like about 58.67, and that's feet per second. Did y'all get that? All right, number 12. What unit rate would be used to describe the temperature change? Well, what kind of units are on the y-axis? Dollars, right? Dollars. And then what units are on the x-axis? But that's not a unit. What units do we measure temperature in? Well, but whether it's Fahrenheit or Celsius, it's degrees. So your unit will just be dollars per degree. That's all you have to do on that type of question. Dollars per degree. And no, I mean, it won't be the exact same, but it'll be very similar. Yes, most of it. There is a few free response, but the majority is multiple choice. All right, number 13. Everybody finished copying? All right, number 13, simplify the square root of 18. To simplify it, you have to factor tree it. But remember, the first thing we do is type it in. Square root of 18 equals 4.24. Okay, so that means it's not a perfect square because it did not give me a whole number. So I need to factor tree it. What are factors of 18? Right? Either could be used. 6 will break down into a 2 and a 3. And then this 3 is prime, so it just drops down. Once you have all prime numbers, you circle any pairs, kill one of them, kick the other one out, and anything not circled goes back inside. Then you check your answer by typing it in. 3 square roots of 2 is the exact same thing as the square root of 18, so I know I did it right. All right, number 14. Square root of 250. The first thing we do is type it in. Second x squared 250. And it does not give me a whole number, so it's not a perfect square. So I need to simplify it via factor tree. What are some numbers that multiply to give us 250? Okay, 25 times 10. Then 25 is 5 times 5. 10 is 5 times 2. And then all 4 of those numbers are prime numbers. So I'm ready to circle any sets of 2. So there's 2 5s there. Kill one, kick one out. Anything not circled goes back inside, and there's 2 of them. So what do you do with them? Multiply them together, so 10. And now we check it by typing in 5 square roots of 10 and see that it matches what we got when we typed in the square root of 250. So that's how we know we've done it correctly. Any questions so far? All right, what's different about number 15? A coefficient. You always technically have a coefficient, but normally it's just an understood 1. But this time the coefficient is a 3, but we're not going to worry with it till the very end. We are going to go and type in from the beginning 3 square roots of 68. That way we're ready at the end to check our answer. We see that it's a decimal, so we know we're not dealing with a perfect square, and we're going to have to factor tree it. What are numbers that multiply to give you 68? Okay, 17 and 4. Say that you're struggling to know numbers. Like, honestly, I don't always just know numbers right off the top of my head that multiply to make 68, but I do know 68 is an even number. So I start dividing it by even numbers, like 2, 4, 6, 8, and I just see what pops up. Okay? Now 17 is prime, so it will just drop down, but 4 will break down into 2 times 2. Now I circle any pairs I have. I have a pair of 2s. One gets killed, one gets kicked out, and then the 17 goes inside. Is that the answer? What have I not done? Right, this 3 was already on the outside, so now it joins the 2 to make 6 on the outside. And now you will check that 6 square roots of 17 is the exact same thing as 3 square roots of 68, so that's how we know we did it right. Am I going too fast? No. All right, number 16, square root of 81. Right, most of you already know it, but just in case, when you type it in, you'll see that it spits out a whole number. That's a perfect square. That's the final answer. Nothing else needed. And the reason it works out like that is because when you did a factor tree, if you did, everything would be circled, killed, or kicked out. Nothing would get to go back in the house. That's why there's no longer a radical symbol, no longer a house. All right, number 17. 3 square roots of 12 plus the square root of 27. They want us to add these, but what's the problem? they're not the same radicand. This one has a radicand of 12. This one has a radicand of 27. So we need to try to simplify each one individually and then see if they match. So let's start with this 12. What are numbers that multiply to give you 12? Okay. Either would work. I also heard 6 and 2. That would be fine as well. 4 breaks down into 2 times 2. 3 is prime. You circle your pair of 2s, kill one, kick one out, put the 3 back in. But for this one, don't forget there was already a 3 that will now make that 6 square roots of 3. Okay, now we do the square root of 27. What are numbers that multiply to make 27? Okay. And then 9 breaks down into a 3 times 3. This 3 just drops. Circle your pair of 3s, kill one, kick one out, and then put the one not circled back inside. And then there was no outside number other than 1, so it's going to stay 3 root 3. They want us to add them, so what's the answer? 9 square root 3. Remember, when you go to actually add them, you don't add the radicands, they're just the like term. You add the coefficients. 6 plus 3 is 9. Any questions about that one? All right, number 18. Okay, this time they want us to subtract the square root of 54 minus the square root of 24, but what's the problem? The radicands don't match. So just like the previous problem, you're going to take the 2 radicals to the side and factor tree and see if we can get them to have matching radicands. What are some factors of 54? Okay? Okay, well, I'll just start with 6 and 9. 6 is a 2 and a 3. 9 is a 3 and a 3. Those are all prime now, so I'm ready to circle, kill, kick out. And then those both are not circled, so they go back inside and make a 6. Now I factor tree the 24. What are numbers that multiply to make 24? Right? 6 is a 2 and a 3. 4 is a 2 and a 2. They're all prime, so now I'm ready to circle the 2s, kill one, kick one out. 2 and 3 get to go back inside and make a 6. Keep in mind they wanted you to subtract these. They now match, so it'll be how many square roots of 6? 1 square root of 6, or just square root of 6. You do not have to write the 1. Now, just like all the other problems, you could also type these in to check your answer. Okay, you would just type in the square root of 54. So square root of 54 minus the square root of 24, and you would see that that equals 2.449. Then I would type in square root of 6, because that was my final answer, and it equals the same thing. So that's how you know you did it right. You should be typing in all of these. You'll have plenty of time. And that way, if they don't match, you know to start the problem over. Okay? All right, number 19. Which number is equivalent to 6 square roots of 12 times 7 square roots of 18? Can we multiply them? Yes. Multiplying rules are different. With multiplying, they do not have to match. You multiply the outside numbers together first. What's 6 times 7? 42. Then you multiply the inside numbers together. What's 12 times 18? Right, just use your calculator. That's why I give you a calculator. All right, now, this is, right so far, but it's not as simple as form, so it would not be one of the 4 choices. We've got to factor tree the 216. Now, I can't even think of numbers that multiply to 216 off the top of my head. But I do notice that it's an even number, so I'm going to start by dividing it by even numbers. Okay, and I heard 2 and 108, that would work. Or you could even try to go bigger. 216 divided by 4 is 4 and 54. You could probably have even gone bigger than that. Okay, but just remember, if you don't know numbers right off the top of your head, it's even. So just start dividing by even numbers. Okay, now 4 breaks down into 2 times 2. 54 breaks down into 9 times 6. The 2's are prime, so they just drop. The 9 becomes a set of 3's, and then the 6 becomes a 2 and a 3. Any questions so far? Okay, everything is now primed, so I'm ready to circle, kill, and kick out. So I circle a pair of 2s, kill one, kick one out. I circle a pair of 3s, kill one, kick one out. This 2 and 3 were not circled, so they both go back in, and they multiply together to make a 6, just like the outside numbers multiply together to make a 6. And then is that the final answer? Why not? Right. This 42 was already on the outside, so now it will multiply by that 6 to make what? 252 square roots of 6. And then just for time purposes, I'm not going to check it on the calculator, but you need to tomorrow. After you're done with this question, you need to type in the question, see what it says, type in your answer, see what it says. That'll save you trouble, because I can see how some of you will get to rushing on the test and leave this as the final answer and forget about the 42. But if you check it, that'll be an indication that you've done something wrong. Okay, and you might, when you see that they don't match, you might immediately realize, oh, I forgot the 42. It's very important to check your answers, and you'll have plenty of time to do so. Okay, any questions so far before we move to rational and irrational? Okay, what makes a number rational? What are the first 5 letters of the word rational? Ratio. So that means it will become a fraction. So the first thing we need to do when they're trying to figure out if something is rational is type it in. Type in the square root of 5. But look, right here, make sure you arrow over to get out from under the radical before you type in plus 4.7. Now, we see that when I attempt to make it a fraction, how do I do that? Alpha y equals number 4. See how it'll take a fraction to a decimal or a decimal to a fraction? So hit number 4. Y equals number 4. Did it become a fraction? No, which means that it is not rational. It would not become a ratio. Right. Now let's look at 21. It's the product, which means multiplication, of the square root of 64 times the square root of 3 irrational. So the square root of 64 times, make sure you've arrowed over before you type in the square root of 3. You get that, and then you do alpha y equals number 4. And it did not become a fraction. So is it irrational? Yes. Irrational means it won't become a fraction, and it wouldn't. So this one's yes. Then number 22 is 2 minus the square root of 3, an irrational number. 2 minus the square root of 3. And then I do alpha y equals number 4 to see if it'll become a fraction. And it will not. So does that mean it's irrational? Yes. Okay, flip to the last page. How can you determine if a number is irrational? Right, it will not become a fraction. All right, number 24. Find the perimeter of the rectangle shown. Okay, so the question's asking about perimeter. What do you know about perimeter of a rectangle? What? Add up all 4 sides, right? Well, since it's a rectangle, if this side of the rectangle is the square root of 20 inches, so is this one. And then if this side is the square root of 45 inches, so is this one. So now we just add up all 4 sides. Well, look, don't all of these have an understood 1 on the outside in the place of the coefficient? So aren't there technically 1 plus 1, 2 square roots of 45, and 1 plus 1, 2 square roots of 20? But remember, we got to add up all 4 sides. Well, can you add those? Well, not currently, because their radicands do not match. And to add or subtract, the radicands have to match. So what do we need to do? Simplify them. Okay, what are some numbers that multiply to make 45? 9 times 5. And then 9 is 3 times 3. 5 is prime. So we circled up the 3's, kill 1, kick out 1, keep the 5 on the inside. And don't forget about the 2. That will make it become a 6 on the outside. Okay, now I need to do the same thing to 2 square roots of 20. What are numbers that multiply to make 20? 2 and 10 are 5 and 4. 2's prime. And then 10 becomes a 2 and a 5. So you circle up the 2's, kill 1, kick out 1, put the 5 back on the inside. Don't forget about this 2, that yes, will make that become a 4. So now they do match. Now we can add them. And how many square roots of 5 are there? 10. Because 6 plus 4 is 10 square roots of 5. So that's the perimeter. All right. I'll give you time to copy that, and then we'll go over the last one. Okay, everybody got it copied? All right, simplify the square root of 5 minus 3 square roots of 5. They want you to subtract them. Can they be subtracted? Yes, they're both square root of 5. Their radicands match. But what do you get when you actually subtract them? What? I'm hearing, say it again, somebody. Okay, but that's decimal form. Remember, they want you to keep it in radical form. Look, isn't this one an understood 1 on the outside? So it's 1 minus 3, which is negative 2. You've got to keep it in this form. You cannot give me any answers in decimal form on this test. They've all got to be in radical form.